So this video reviews and then practices the process for solving and graphing inequalities. And so when it comes to solving inequalities, there are three things we need to remember. First, we need to remember that, like equations, we need to balance inequalities when we solve them. What you do to one side, you must do to the other. And along with that, in terms of solving inequalities, we need to remember to show our work. Most important thing about this process is showing the balance that's happening in the inequalities so that anybody who's looking at it can guarantee that what you're doing is not only the correct calculation, but will give you the answer you're looking for. The second thing is that the solution to an equation is one number, but the solution to an inequality is a complete range of numbers, not just a single answer. And finally, one little extra thing that we have to worry about with negatives, because inequalities are based on the relationships between the absolute values of numbers, and that those are backwards between positive and negative numbers, is that when we multiply or divide an inequality by a negative number, when the thing that we're doing is negative and it's multiplication and division, then we need to flip the direction of the inequality sign. Because even though 1 is less than 2, negative 1 is actually greater than negative 2. So we have to worry about that. And the second part of this is graphing inequalities. If we had a basic inequality like x is less than 12, first, we would draw our number line. That's what it means to graph, is to plot it on the number line. Our key number here is 12. And that's what's going to separate our number line into the parts of the number line that are less than 12 and the ones that are not less than 12. So the part of the number line where x is less than 12 is everything in the direction of negative infinity. We can check like 0 and say, okay, well, 0 is less than 12. So that part of the number line must be the area that works. And so we cover everything with an arrow to indicate that everything covered with this arrow is a part of the solution. However, when we get to 12, 12 is not actually less than 12. If it were less than or equal to, then 12 would be part of the solution, but it's not. And so to show that 12 is not part of a solution, we have what we call an open circle around 12. And then the arrow goes right up next to it. So that is how we graph an inequality. If it were less than or equal to or greater than or equal to, the circle would be closed, that is filled in. But for the moment, it's not because x is strictly less than 12, and 12 cannot be a part of that solution. So the first 8 inequalities that we have, or rather the first 6 inequalities that we have for practice, are pretty basic inequalities. They just involve one step. And so I'm going to ask you to solve these inequalities and then graph their solutions on a number line. Here are your first 2 problems in red. Go ahead, pause the video, see what you can do, and then come back when you're ready to go through the solutions. So first, we're going to add 7 to both sides, because right now x is being as having 7 subtracted from it, so we add 7 back to clear that operation. 12 plus 7 is 19. So x is greater than or equal to 19. Here's our number line. 19 is our key number there. It is greater than or equal to, so we're going to fill it in with a closed circle, because 19 is a part of the solution, and we want everything that is greater than 19, which is this way. So closed circle, arrow to the right, x is greater than or equal to 19. For the second one here, for 3x is less than negative 27, we'll divide by 3. When we divide by 3 on the left-hand side, we get x. On the right-hand side, we get negative 9. And even though negative 27 is a negative number, we only flip the inequality when the operation that we're doing to the equation is a negative multiplication or division. Right now we're dividing by a positive 3, and therefore our inequality stays in the same direction. So here's our number line. There's negative 9, that's our key part. It is an open circle because it is strictly less than negative 9 and not less than or equal to, and the arrow is to the left. We want everything less than negative 9. So here are the next 2 equations for you to work on, or rather the inequalities. Go ahead, pause the video, see what you can do, and come back when you're ready to go through the solutions. All right, so for the one on the left, we're going to multiply both sides by negative 4. We need to clear the entire operation, which is division, so we undo it with a multiplication. Here we are operating on the inequality with a negative multiplication. So on the left, we have x. On the right, we have negative 36. And because we're multiplying by a negative number on both sides, the sign needs to turn around to go from a less than sign to a greater than sign. So here's our number line, negative 36. It's an open circle because it's a greater than and not a greater than or equal to, and it's everything greater, so it's towards positive infinity or the right side of the number line. For the next one, we're just going to take 3/4 away from both sides. End up with x on the left-hand side. On the right-hand side, 1/2 minus 3/4 is negative 1/4. And so that's our solution. Everything for x that is greater than negative 1/4 or equal to is part of the solution. It's an or equal to, so it's a closed circle filled in, and we want the greater side, which is always to the right. So there's our solutions for those two. Last two basic inequality problems, then we'll have 4 more that are multi-step and a bit more complicated. But go ahead and pause the video, see what you can do with these 2 problems, and come back when you're ready to go through the solutions. So for the one on the left, we're going to take a 9 away. To get x is less than negative 5 minus 9 is negative 14, so x is less than negative 14. Then on our number line, negative 14 is our most important number there. And then we have an open circle because it's just a strictly less than and not a less than or equal to, and it is less. So we're shading into the left, so that's our solution for x is less than negative 14. And then for our second one here, we divide by 4. And then on the left-hand side, we get x. On the right-hand side, we get 7/4. We can just leave it like that. That's also 1.75, but we can just leave it there. Then on our number line, 7/4 is our point where our number line switches. It's an open circle because it's not or equal to, and then the arrow is going to the right. And so now we're going to get into some more complicated inequalities, one that involves several steps. Actually, all of them involve 2. So go ahead, pause the video, and see what you can do about solving these kinds of inequalities. So for the one on the left, we're going to add 1 first. To get 3x is less than or equal to 17, and then divide by 3. This is a repeating decimal, so we're going to leave it as a fraction and have x is less than or equal to 17/3, which if we were to turn it into a decimal would be 5.6 with the 6 repeating. But then on the number line, our key number 17/3 would go right there. It's a less than or equal to, so we're going to have a closed circle filled in, and then less than, so towards the negative infinity rather than positive infinity. For the one on the right, we're going to add 2 to both sides to start off with. That gives us x over negative 4 is greater than or equal to 2. Then we're going to multiply both sides by negative 4. Again, this is a multiplication by a negative number on both sides of the inequality. So the left side is x, the right side is negative 8, and the inequality flips because we are multiplying by a negative number. And then since x is less than or equal to negative 8 is our number in the middle. Closed circle because it is an or equal to, and then off to the left towards negative infinity for all the numbers that are less than negative 8. Last 2 problems that we're going to do. For the one on the left, remember that anytime we have things like that, we can always either distribute or divide first. It's up to you. And then the one on the right should be fairly familiar. So go ahead, pause the video, see what you can do, and then come back when you're ready to move on. So for the one on the left, we have 2 options. If you divide by negative 2 first, remembering that you have to flip the inequality. Then you can just get to x plus 9 is less than negative 16 and solve it that way. I'm going to go through the process. We'll get the same solution, but I'm going to go through the process by distributing. So that is negative 2 times x plus negative 18 is greater than 8. Then we're going to add an 18 to both sides, because adding 18 and adding negative 18 are inverse processes there. So then we have negative 2x is greater than 26. Then divide both sides by negative 2 and end up with x is less than, because this division is a negative number, negative 13. On a number line, here's negative 13, open circle, less than. And then for our last problem, we're going to add 7 to both sides first, get 4x is greater than 5, then divide by 4 to get x is greater than 5/4, or you can write it as a decimal if you prefer, which is 1.25. Number line, 5/4 is our most important number there. Open circle because it's strictly greater than, and everything to the right because we are looking for all the numbers greater than 1.25. So as a quick reminder, all those things that we need to worry about for equations with balance and having a particular solution is always true. The solution to an inequality, though, is a range of numbers, not just a single number. And then we need to flip the direction of the inequality sign when we multiply or divide the inequality by a negative number.